All right, we have a fantastic lunch speaker. This is a real treat to welcome Dr. Bjorn Lomborg to Steamboat Institute. Dr. Lomborg is the president and founder of the Copenhagen Consensus Center. He is the author of the best-selling False Alarm: How Climate Change Panic Costs Us Trillions, Hurts the Poor, and Fails to Fix the Planet. He will be signing copies of your books that you brought with you in the foyer after his presentation. Dr. Lomborg challenges mainstream concerns about development and the environment and points out that we need to focus the attention on the smartest solutions first. He's a visiting fellow at the Stanford University's Hoover Institution and, of course, president of the Copenhagen Consensus Center, which brings together many of the world's top economists, including 7 Nobel laureates. Dr. Lomborg is a frequent participant in public debates on policy issues. His analysis and commentaries have appeared regularly in such prestigious publications as The Wall Street Journal, USA Today, The New York Times, The Economist, and many, many others. His monthly column appears in multiple languages in influential newspapers across all the continents. He's also a TV commentator on CNN, Fox, MSNBC, and the BBC, among others. He's also been on many news programs that you watch, 2020, 60 Minutes, and many others. In 2011 and 12, Dr. Lomborg was named the top 100 global thinker by Foreign Policy for looking more right than ever on the politics of climate change. Time magazine ranked him among the world's 100 most influential people in 2004. And in 2008, Esquire magazine named him one of the world's 75 most influential people of the 21st century. Following his remarks, Dr. Lomborg will be joined on stage by Jackie Pick-Deason to take your questions, so be sure to submit those questions. Let's give a warm Steamboat welcome to Dr. Bjorn Lomborg.
They're selling make-believe and we don't buy that here. 'Cause in the real world they're shutting Detroit down.
Thank you, guys. Yeah, so they shouldn't have this long music, right? Because you sort of stop clapping while I'm arriving. So look, I'd love to talk to you about how we think about climate change and how we should think more smartly about this. You've heard a lot of facts throughout this morning, and I'm going to be emphasizing some of them. I'm also going to try and give you a sense of how do we do the whole argument. Because I think it is important that we start having a conversation about, are we doing the right thing on climate? And that actually takes multiple steps. I'm going to just try to spend about 35 minutes, so we have plenty of time for Q&A afterwards. So look, I'm simply going to jump in. I'm a social scientist, so I'm not a natural scientist. I talk to a lot of them, but that's not what I do. I'm simply going to say, global warming, it's real, it's man-made, it is a problem. But it's also often exaggerated. And this is important because if you think this is the end of the world, I don't know if you saw at the very first show, we see AOC telling us the world is going to end in 12 years. If that was really true, it makes a lot of sense what she says is, if the world is ending and you're worried about how to pay for it, you should just be, if it's a meteor hurtling towards Earth, we should just throw everything else aside and give all the money to Bruce Willis and get up there and do something about it. So the point here is to say it's because it's exaggerated that we're actually making really bad decisions. And so I want to share with you some of these things. And just to give you a sense, and we've heard a lot of this, and Steve Koonin also gave you some of these quotes. Guterres, our UN Secretary General, is perhaps the best sort of source for these kinds of exaggerated claims. He tells us the world is facing a grave climate emergency. Every week brings new climate-related devastation, floods, droughts, heat waves, wildfires, superstorms. We hear all of this, and we're in a battle for our lives, and climate change is the biggest threat to the economy. These claims are mostly false. They're not entirely wrong, but they're mostly false, and I'd like to show you why. Again, if I'm just going to do 35 minutes, I'm just going to give you some of those tidbits, and I'm sure we can take up some of the other ones. Of course, I describe in my book and my period articles and so on. But let me just take you through a few of these. So do we see all these super storms or hurricanes, as a lot of people like to point out. Well, if you look at the UN Climate Panel, the so-called IPCC, they tell us in their latest report, in the past, identifying past trends in tropical cyclones, that's what they call hurricanes, remains a challenge, and low confidence in most reported long-term trends. But for the future, they do tell us we will likely see more really strong hurricanes. We will probably also see fewer future hurricanes. You need to know both. Now, overall, that's a net negative because stronger outweighs fewer. So there is a problem, and we are going to see more damage. But it's also important to get a sense of proportion, right? You hear this constantly, that every hurricane you hear, that's the end of the world, and this is because of global warming. And again, one of the problems is we have very, very bad long-term trends. This is fundamentally because it's really hard to go back to 1900 and expect most hurricanes have been noticed back then. Of course, we notice all of them now because we have satellites. So how do we adjust for that? Well, if you look at the best long-term best long-term data source, that's US landfalling hurricanes, because since 1900, it's very unlikely that there was a hurricane that hit the US and nobody noticed. So we have good evidence for this. And actually what you see is not an increasing trend. It's a slightly decreasing, it's not significant. But fundamentally, it's not increasing. And again, people will then tell you, oh, but there's going to be more strong hurricanes. Of course, we also have for strong hurricanes, for major. And again, not increasing, actually, if anything, slightly decreasing. We need to tell this. We also have reasonable evidence for landfalling hurricanes back from 1945 for the two major hurricane basins, and they show the same thing. The fundamental point is the data does not tell us that right now things are getting out of hand. But it doesn't mean that there's not a problem. There is a problem in the future, and that's one of the things that we'll talk about. But again, it doesn't warrant this exaggeration that we get from Guterres and a lot of other leaders. Likewise, if you look at wildfire, I mean, I picked this, it's in the public domain, that's why I'm showing it. But these pictures are cool. You understand why newspapers would want to print them, because they get you to click on this. This looks terrible. This looks frightening. This is something that we don't want, right? So clearly, the sense we get when we listen to the media is that there's more and more fire. New York Times just recently did The World is on Fire, where they looked at fire across the entire world. It's a common trope to say the world is on fire because of global warming. Actually, we have good data. And again, the point that I try to make is let's get the data to actually get a sense of what does it tell us. Well, we have good data back from 1900. The first, of course, is modeled because we don't actually have good evidence for the entire planet, but almost everyone accepts that this is probably what it looked like. In the early part of last century, about 4.2% of the Earth's surface burnt. And today, or just around 2000, it is probably down to about 3.2%. From the late 1990s, we actually have very good data because we have satellites circling the world all the time and picking up. And that satellite shows that we've seen a decreasing amount from about 3.2 now down to about 2.5. The world is not burning more, the world is burning less. Why? Mostly because most people don't want stuff to burn. It's not really very complicated, right? And that's, of course, why we adapt to this. We actually make sure stuff doesn't burn. It's not rocket science. But again, if we don't want to scare our kids, if we want to have a good data sense of where should we start, what should we be concerned about, we need to know this data. We very often don't. What's going to happen into the future? Well, if you only look, and this is what most climate models will do, if you only look at temperature and assume temperature is going to rise, that means you're going to see more fire, all other things equal. But of course, all other things are not equal. One thing is that we also going to have more CO2, which means we're going to have a greener planet, which means we'll have a different combination of greenery on most places in the world. If you just run that, you probably get less burning, not more. And if you include people, that is, people actually act, you definitely get that this trend we've seen over the last 120 years will continue. So if we do nothing, if there's no climate policy, the world will keep burning less and less. But if we do climate policy, it will burn even less. But the point here is, and this is the important part of the conversation, global warming is not something that makes the whole world burn. You know, this is not going up. But it makes the world burn slightly less than it otherwise would have been. That's a very different kind of conversation. All right, so do I want a world that's better, or do I want a world that's even better? That's a good conversation, but it's a very different one from the one where we have the catastrophe waiting right around the corner, which it's not. So that's the first part of it. We're vastly seeing an exaggerated argument. And that, of course, leads to a lot of bad decisions. Why do we get this so wrong? Because of adaptation. We typically ignore adaptation. And I'm going to show you some of these costs. Also, Dessler mentioned several times it's a little unfair because Dessler had to leave, so he can't really defend himself. But I'm going to do it anyway. So we have good. I talked to him out there, and I told him about the resources. I'm going to send them to him as well. We have good evidence on some of these costs of adaptation, and they're not exceptional or incredible or something. They're about 0.1% of GDP. They're not zero, but they're certainly not huge. So let me just show you. Alex already stole my thunder in this one, but I still think it's important to point out, you know, if you ask most people, what has happened with deaths from climate-related disasters, so basically floods, drought, storms, wildfire, and extreme temperatures, we have good data for about 100 years. And it's not such, most people would imagine that this just goes up. That's certainly what we get the impression from the media. No, actually, in 1920s, almost 500,000 people died every year from these climate-related disasters. And since then, this has been declining and declining and declining. So that in 2010s, it was about 18,000 people. In 2020, it was 14,000. And in 2021, the day or the year where you heard about all these catastrophes, you remember the heat dome, you remember the floods in Germany? Well, there was a lot of other things you never heard about. For instance, 1,000 people died in India floods, there's 2 Afghan flash floods, and so on and so on. If you add up all of those, less than 7,000 people died last year. Why do we hear that more and more people die when the truth is fewer and fewer people die? This has very little to do with climate change, but it has everything to do with the fact that when you're richer, you're more resilient, and hence you don't die as much. We need to know this to stop being scared witless, because if we're scared witless, we're unlikely to make good decisions. So let me just show you, thank you. So let me just show you another instance, and this is very much on Dessler's point. So how much is future flooding actually going to address this? This is one of the most quoted papers, Hinkle 2014. Wow, you can't actually read the, no, you can. Sorry, it's just my monitor. 2014. So it's very hard to estimate how many people are actually affected by flooding, because are you affected by flooding? That's a very elastic number. They use a lot of models, and this is basically showing you what the average of all these models is. They tell us that in 2000, every year, 3.4 million people were flooded because of, typically, they just lived terrible lives, right? This had a cost of about $11 billion. We also spent about $13 billion in dike cost. The total cost was 0.05% of global GDP. First of all, that's not a whole lot, right? You hear a lot more about this than you'd actually imagine that the costs are worth. 0.05, yeah, it's a problem. It's certainly not one of the biggest problems in the world. What then happens if you take a look at the worst case warming, the highest population, and the highest GDP? So I'm just going to show you one. This is true for all different kinds of scenarios, but I'm just going to show you, if you will, the worst one. What happens if you just assume there's no adaptation? You get this. You get a dramatic increase, right? By the end of the century, about 187 million people are going to get flooded each and every year. This number has been repeated in New York Times and Washington Post and their leaders and their op-eds, many other places. It's been published widely, and it tells us, you know, if you know David Wallace Wells, this is one of his main points, this is going to cost us $55 trillion every year. It's also going to have $24 billion in dike costs. Dike costs are not going to be very high because we didn't bother to do anything about the dikes, right? And it's going to cost 5.3% of global GDP. The important point to remember, though, is This assumes that everybody over the next 80 years stand there and just watch sea level rise and say, this is getting uncomfortable. And you start getting it up over your knees and your hips, and eventually you get really old, and you get really uncomfortable, and maybe you even drown. That was what Rolling Stone said. This is going to drown 187 million people. No. I mean, first of all, they'd probably move, but more likely is that they would adapt. We've actually done this, right? Remember, if you go to Holland, you see a very good example of people who have adapted. If you've ever flown into Amsterdam, Schiphol Airport, it's the world's 14th largest airport, and it, on its website, points out that we're the only major airport in the world that was previously seen for a major naval battle. And it's not like you're there and you're thinking, oh my God, it could be flooded at any moment. We know how to deal with this. Now, Tesla tells us this is going to be incredibly expensive. No, it's not. We know this because people have done the models. So this is what happens if you assume adaptation. You almost can't see the difference, right? By the end of the century, we will have 15,000 people flooded. How come that we can have seen sea level rise about 3 feet and many fewer people are going to be flooded? Because we'll be much richer and because we know how to deal with these issues. We will also have a significantly increase in flood costs. It's not going to be 55 trillion, but 38 billion. We will also have to spend much more in dikes, so we'll be spending $48 billion in dikes. Remember, Tesla kept on saying that Houston is going to cost $10 billion? That's probably true, but this is once over the century. And of course, across the whole world, this is not going to be free, but it's not going to be a big imposition. So the results showed that it's about 0.1% of GDP across the world, across the century. This is certainly something we can afford. The total cost, and this is important, the total cost of flooding and of dike cost is now going to be 0.008%. So the amazing thing is, despite sea levels rise, because of adaptation, we will see much lower damages overall. We'll see only 15,000 people instead of 3.4 million people, and we will see less damage, that is 0.08%, rather than 0.008 instead of 0.05, almost 10 times less. It shows you the ability of adaptation. And when we ignore it or forget about it, we are likely to be vastly over-worried about climate change. This does not mean that there's no problem. Again, had we done climate policy here, and I can't show you this because you wouldn't be able to tell the difference, if we had done adaptation, if we had done climate policy, if we dramatically reduced our emissions and almost gone net zero by 2050, we could have reduced the number of people flooded in 2100 from 15,000 people all the way down to 10,000 people. That's a better world, but it's not like this is really what matters, right? It's the 3.4 million down to 15,000 that matters. It's the adaptation that really matters, not the climate policy. What is the cost? And Alex briefly alluded to that. Well, again, we have good global costs from 1990, and we've again seen a decline in the cost, not an increase. And this, of course, again, is because richer societies are more resilient, better able to deal with this problem. The point that I try to get through here is to say, global warming is a problem, yes, but thinking it's the end of the world, thinking it's going to burn the whole world, that we're going to have superstorms everywhere, and that we're just going to see the cost escalate out of hand is simply not in keeping with the facts. So the problem is that right now we're being told, well, we need to go net zero. Andrew Dessler was sitting up here and saying, it's going to be fantastically cheap, which of course, as Alex also pointed out, is somewhat belied by the fact that nobody seems to want to do it unless they get their arms twisted, right? It seems weird that this would be a great idea if you have to twist everybody's arm and they still really don't want to do it. But let's just take a look at what has actually happened. If you take a look at the share of renewable energy since 1800, what we've seen since 1800 is a dramatic reduction, right? I mean, we used to get almost all of our energy from renewables because we had very little. Then we realized, oh, wait, we can get a lot of energy. And we did that. And that's what we've been doing for the last half century. We've been down at 13 or 14%. This is from the International Energy Agency, right? What you see here in after 2000 is a slight increase. That's what our climate policies has brought. If you look at the envelope of what we're likely to see, this is from the International Energy Agency, from the UN, several others, we will probably see this prediction. We might get up to 20% by 2050. But what our leaders are saying is, no, we should go up here. It's important. Somebody calls this the Narvale chart. And it's important to recognize how out of character this is. It is just simply, historically, absolutely implausible. Just to get a sense of proportion, to go net zero, we would have to build 2 nuclear power plants every 3 days for the next 11,000 days. There's about 11,000 days till 2050. We have achieved nothing like that. We're achieving about, in the next 6 years, perhaps 7 nuclear power plants per year. So we're nowhere near this. Or we'd have to build 1,500 wind turbines on an area that's equivalent of all the 5 boroughs of New York every day. We're achieving about 1/10 of that. And we'd have to retire a coal plant every day. Not surprising, I don't need to say, that's not what we've been doing. We've actually been building one at least every week for the last 21 years. We're simply not there at all. And this, of course, is why the cost of going net zero is going to be phenomenal. So Bank of America estimates the total cost of going net zero is going to be, the global cost is going to be $5 trillion every year from 2021 to 2050. $5 trillion. I know we've gotten a little inured. What is the word? Inured? We're sort of, trillion. But it's actually a lot of money. It's worth just pointing out, right? This is a lot of money. And they also assume that this will actually lead to about a 3% additional annual greenflation, as they call it. This is not cool. This is not what we like. This is going to be phenomenally costly. If you look at a new Nature study, it actually shows that net zero will cost each and every American more than $11,000 per person per year. So notice, if we just cut 20%, that's going to be cheap. That's $75 per person per year. Most Americans would actually accept that. When we survey them, they probably give you about $100, $200 to fix climate. So this could be done. 40% already stretching it, right? 60% no, 80% no, and 95% no. Right? That's just not going to go. You're not going to get people to say, sure, I'm going to spend $11,000 each and every year being that much poorer, that much colder, that much more uncomfortable. That's just not going to happen. I don't know if you saw a new study from McKinsey, just showed that net zero is going to cost $9.2 trillion every year. Again, they had a really bad chart, so I'm taking this from Bloomberg, which gives you the same. This is the cost in percent of GDP for different nations. As you can tell, this is going to cost 7.5% of global GDP every year for the next 30 years. Just to give you a sense of proportion, this would mean that we would have to spend half of the entire global tax intake of every nation on the planet to do net zero. Can I just get us to think about that for a second? Are most nations going to say, sure, we're going to spend half of our tax intake on this? No. I don't know if you saw, India promised in Glasgow, Coonan talked about that. India promised that they were going to go net zero by 2070, which is a lot far away. But they promised it. And then 5 days later, they came out and said, there's a little asterisk. Sorry, we forgot to say that. If you want us to go down that route, you have to give us $1 trillion before 2030. And there was no takers, I might add. It's going to cost 6.4% of GDP for the US, which is $1.5 trillion this year. According to the COB, that's about the cost of the scaled down Build Back Better. That's a Build Back Better plan every year for the next 29 years. Again, it's hard enough to, apparently we can't get one Build Back plan through, right? Imagine getting 29 of them. This is simply unsustainable. There's no way you can get politicians to be reelected to have these kinds of costs. And again, and I think this is worth pointing out, sure, you might be able to get this for some rich, well-meaning Americans and Europeans, but that's a trivial part of the world. You're not going to get most South Africans, Sub-Saharan Africans, the poorest people in the world to say, sure, I'd like to spend 10% of our national income every year on net zero. Or the Indians again. This is just, it's fantasy. So I want us to start thinking about, why is this so costly? Because we're not ready. We're essentially trying to do everything without the appropriate technology. I just want to emphasize one thing, and Andrew Dessler also brought that up, and a lot of people will say that, sure, solar and wind is intermittent, but batteries. Well, no, batteries won't actually save us. This is the amount of batteries that we have if we translate this into the average electricity and say how many minutes of batteries do we have. If you look here on the global level, oh, sorry about that. I pushed the wrong button. If you look here on the global level, we have about 1 minute and 15 seconds of batteries right now, right? So if the sun dies down, happens every night, by the way, or if the wind dies down, we have 1 minute and 15 seconds, and then we're out of batteries. By 2030, we will have a little more than 10 minutes. Remember, the average time the sun is out is about, what, 12 hours? And the average time wind is out every year, in Germany, for instance, is 5 days. So it's 7,000 minutes. This is just nowhere near what it's going to take. Of course you can do anything you want if you're willing to pay for it, but it's the $9.2 trillion that makes this impossible. That's why I would argue we need to get smarter. And I just want to wrap your head around before I actually get to, so what should we be doing? The World Economic Forum in January of this year asked all their eminent people, so more than 4,000 people, what are the most severe global risks for the next 10 years? This is what they did, and I'm going to show you this like we do the European Music Song Contest. I'm going to show you from behind, right? First, 3, biodiversity loss, 2, extreme weather, and 1, climate action failure. Really? I don't know if you guys noticed, but we've just come out of the worst pandemic in a century. We have global inflation and possible recession. We have an increasingly authoritarian China, and just now, we have a Russian invasion of Ukraine. There is something fundamentally wrong about a world where all of our leaders can come out and say, no, it's biodiversity loss, extreme weather, and climate action failure for the next 10 years that really matter, when it's so obvious that there are other and bigger and more important challenges. And this, of course, is why, in many ways, the Russian invasion has become this wake-up call. It's a realization that, wait a minute, maybe we're not worrying about the right thing. Remember, we're an advanced species. We can walk and chew gum at the same time. Just because there are bigger problems out there doesn't mean we shouldn't also be concerned about global warming, but it means that we possibly should get it in the context of how much should we worry. So I'd like to just show you how should we do smart climate policy, and then wrap up with what I think is the solution, and then I'd love to hear your questions. So look, the point of the last 30 years of climate economics has been to make this one point. This is what the Nordhaus, Kuhn mentioned it, William Nordhaus of Yale University, this is what he got the Nobel Prize for. So if you can come up with the similar sort of two-liner, you're in line for a Nobel as well. Fundamentally, what it says is, climate means costly damages. This is what you hear all the time. This is absolutely true. But climate policy also means costly damages. Given that we have to pay both, we have to find a world where the sum of those two is the smallest. This requires us to get a sense of proportion. How big of a problem is global warming? This is the chart from the only guy who ever won the Nobel Prize in Climate Economics, William Nordhaus. This is his estimate from 2017. This was also what the UN estimated in 2014. These are all the different studies. Greater circle means that we have more confidence in the studies. And as you can see, as temperature gets higher, so we get further out on the temperature increase, the damage cost gets wider. And this is what Nordhaus estimates. This is probably the best estimate of the total cost of climate change, including emitted damages, which of course is really hard because we haven't studied it, but that's a conversation for a whole other time. So if we're assuming that we'll probably end up around somewhere, 4 to 6 degrees Fahrenheit more, we'll probably have damages from, say 2 to maybe 4% of global GDP. This was what Kuhn mentioned when he said, a couple degrees of temperature increase in centigrade means a couple percent in damages. This is a problem, yes. It's not the end of the world. I just want to spend a few seconds, and I'm sorry, this is going to go into the deep weeds. Kunin mentioned this, but the new UN climate panel report has come out and said, well, we're not quite sure about this because there are some estimates out there that are much, much worse. I'm just going to show you the most prominent much, much worse, namely one that suggests that here we would have a damage cost down here. It's absolutely ridiculously off, but I want to show you how. So it's called Burke 2015, and there's an update from 2018. It basically estimates that climate is going to cost us 23% of GDP by 2100. This is wrong, and I just want to briefly tell you why. It shows that historically, economies grow faster when they're around 55 degrees Fahrenheit. It kind of makes sense. If it's really cold or it's really hot, you're just not as productive. We know that, that's probably true, and that's what he uses as his basic argument to say, well, when temperatures rise, we're going to see some of these very cold countries, I come from one of them, right? They're actually going to become more productive, but then a lot of countries, like the US and many others, are actually going to go on the other side of that hump, and they're going to grow less fast, and that's what's going to really do us in as a humanity. Now, this assumes some really, really bad modeling. First of all, there's a lot of papers that actually show this is simply wrong. I put it more politely and say it's implausible. It assumes an incredibly unrealistic scenario of emissions, but mostly it ignores adaptation. So it assumes that this vulnerability that we have today will also be the vulnerability that everybody on the planet will have in 2100, which is just so unbelievable by so many different standards. One is that they actually found that we adapted faster over the last 40 years than what they're assuming in the entire period. It also assumes, not surprisingly, that Iceland will become the richest country in the world by a very wide margin. You can imagine why, because Iceland is really cold, and they actually get to be much warmer, so they're going to grow vastly out of everyone else. Iceland is going to rule the world at $1.5 million per person. If there had been no climate, they would only be at about $200,000 per person. And the biggest leapfrog is Mongolia. Mongolia, which would just have been a backward country also in 2100, but because they're so cold, they will actually be an incredibly rich country. These are the guys we need to watch out for. If you believe this, if you think, yeah, that sounds right, you're in for Burke. And I have some other things I want to sell you. Otherwise, this is simply bonkers. But this is the kind of argument that's used to say, no, maybe it'll get much costlier. No, it will not. That's not what the Nobel laureate tells us. This is not what most of the research tells us. It actually tells us this is the cost. Just to show you what's the impact here. So the UN makes estimates of how much richer are we going to be throughout the century. They need to do this because otherwise you can't run the climate models. I'm just showing you the median scenario, so the sort of middle of the road scenario. And what they show is that over this century, we're going to get a lot richer. So the average person is going to be 450% richer by 2100 than he or she is in 2020. So we were at about $19,000 back then. We're going to be almost at $86,000 in 2100. That is an amazing achievement, right? What will happen because of global warming? Because global warming is going to make this worse, we actually are not going to see this, but we're going to see a slightly different trajectory, right? That leads us to 434% richer. The important point to recognize is global warming means that instead of us being 450% richer by the end of the century, we will only be 434% richer. Yes, that's a problem. No, it's not an existential threat. It doesn't mean we are going to end up dead, all of us. We're going to be much better off. But of course, we can still have a conversation about could we make that gap a little smaller? But that's what the conversation about climate change is. It's not this end of the world. It's a question about how do we make an enormously much better world by 2100, a tiny bit even more amazing. That's a very different question. This is what Nordhaus shows, and that's what I just want to briefly share with you, and then I'll wrap up. He tells us what is the cost of if we do nothing. Well, the cost, not surprisingly, is pretty significant. Climate change is a real problem, as Dessler also pointed out, because we're all adapted to current temperatures. If temperatures change, if they go up, it's going to be costly. So his estimate is that over the next 500 years, the cost of not doing anything will be in the order of $140 trillion. That's a lot of money. Remember, the whole worth of the globe is about 4,500. So we're still talking about a fairly small bit. It's about 3%. But it's not nothing. If we reduce temperatures, we will see less damage. And this, I would argue, is the standard story that all of you have heard. The lower the temperature, the less cost. That's absolutely true. But it's not the only cost we have to pay. We also have to pay a policy cost. Now, what's the policy cost of not doing anything? Nothing. But if we start doing something, and remember, we're assuming that everybody would do reasonably smart, not amazing, but reasonably smart policies, the cost of getting to 6.75 is about $20 trillion. The cost of getting to 5.3, and this looks better in Celsius, that's why it looks this weird, is about $100 trillion, and then it gets just more and more costly. This is the diagram you never see. Yes, climate is costly, but climate policy is also costly. Given that we have to pay both, we really should add up both of them. This is how you get a Nobel Prize, right? So you basically say, all right, this is the cost from climate. But then you also have the add-on cost. There's no add-on cost for no policy, then there's a little add-on cost, and then it's bigger and bigger from a realistic policy cost. It doesn't take rocket science to say, what's the best thing to do for our kids and grandkids and everybody else on the planet? It's this one. This is the optimal outcome, where we actually weigh the cost of both climate and climate policy. This was what Nordhaus found, and this is the story that we ought to hear, but we almost never hear. So I'm just going to wrap up and say, so what should we do? Well, we know a lot of things. I haven't shown you all of this, but I just want to briefly show you. We know some of the existing climate policies. So the EU 2020 policy, which was concluded in 2020, is one of the best analyzed studies. We know that for every dollar spent on climate policies, we achieved about 3 cents of climate benefits. Now, that's not nothing, but it certainly ain't very good. I mean, you just have handed out the dollars and people would have been 97 cents better off, right? If we look at the Paris Agreement, if we assume that people will do this smartly, we will probably do about 11 cents of good for every dollar spent. Again, a really bad idea. If we do a smart global carbon tax, which is going to be hard and be difficult and probably not going to happen in many places, we could actually do some good. That's what Nordhaus shows. If we do this smartly, if we do it reservedly, if we have a small one that ramps in and goes up across the century, that would actually be a pretty effective policy. Every dollar spent would give you $2 back, but it wouldn't solve most of climate problems. And that's why, and I ran a project together with 47 of the world's top climate economists, 3 Nobel laureates, where we looked at where can you spend resources and do the most good, and what they found was, by far, this is about green energy innovation. Every dollar spent on green energy innovation will give you $11 back. Why? If you think about it, it's really very, very simple. Right now, the reason why it's hard to do climate policy is because we're asking everyone on the planet to do stuff they don't want to do. This is why we keep coming up short, right? This is why everybody goes to Glasgow and say, no, you go first. No, you go first. Right? And everybody says, okay, I'm going to promise something unrealistic in 2050 if you do it too. And then everybody says that, and they sign it, and they all get all the applause. But of course, they never actually do this because it's really costly, and it gets you booted out of office if you actually do this. As long as climate policy is incredibly expensive, you're never going to get anything but this signaling, oh, I'd like to show you I'm a really great guy. However, if we could innovate the price of new green energy down below fossil fuels, we'd be done. Everybody would just buy it. You wouldn't need all these grand, big UN conferences. Everybody would just get on with it. That was Alex's point up here. If solar and wind with lots and lots of batteries or other backup opportunities was cheaper than fossil fuels, China and India would be doing it. The point that we need to make sure is that we make that happen. Now, we can talk for ages about should third-generation nuclear power be cheaper? Probably should be, but it probably won't be. However, if we invest in fourth generation nuclear like Gates and many others are doing, if we make that cheaper than fossil fuels, we're done. If we could make batteries and solar and wind and everything else incredibly cheap, we could possibly actually lift quite a bit of this. This is not going to happen in the next decade or two, but eventually it might happen. Craig Venter, the guy who cracked the human genome, has this great idea of basically using algae out on the ocean surface. These algae would just soak up sunlight and CO2 and produce oil. We could basically have a floating Saudi Arabia out in the Pacific Ocean, right? We'd harvest it, and we would run our entire fossil fuel economy on this oil. And it would be CO2 neutral because, just 6 months ago, it actually soaked up that CO2 out there. This is vastly inefficient right now, but maybe it will be efficient. There's thousands of these kinds of ideas, and we just need one or a few of them to come through. That's how innovation works. If you think about it, the world has never solved problems by saying, all right, we're going to promise that everybody feels really bad and they're going to be worse off and they're going to be a little colder and it's going to be inconvenient, but we'll do it to solve a problem. That just doesn't work. How we do solve problems is through innovation. If you think in the 1970s, the world it felt a little bit like it, and a lot of nations were running out of food. The answer was not to tell everyone, I'm sorry, could all of you guys just eat a little less and be a little more uncomfortable, but at least we'll be able to save the Indians and the Africans? That doesn't work. What did work was the first green revolution. We basically made these seeds that produce a lot more for every acre of food. And that's why we have now, today, India is the world's leading rice exporter. So the point here is, it's all about innovation. By all means, let's try and do the carbon tax. I think it's going to be phenomenally hard. But the real solution to climate change is going to be innovation. It always has been the only big solution to any big global problem. And it certainly is that today for climate. But that requires us to realize it's a problem, but it's not the end of the world. Thank you very much. Should I?
Yes, ma'am. Hello, Bjorn.
Hi, thank you.
Fantastic presentation. Thank you.
Thank you.
We have lots of questions from the crowd. To start off, Dr. Lomborg, you started by saying climate change, it's real, it's man-made. Wouldn't it be more accurate to say it's real and some of it is man-made?
Yes, it would be. Again, I think fundamentally having this discussion where you say, you know what, I only think it's 55%, it just gets us down this wrong road of saying this is not really a problem, or I'm not quite sure it is. I think there's value to that conversation, but I think there's much, much more value to tackle people head on. Because remember, most people are not Kuhnen, and most people have no idea what these climate models mean. But most people know what it means to fill up your car with 7-gallon gas, and they don't like it. So I think there's a much stronger argument to be made in the economic sphere, and that's why I'm simply trying to skip ahead and say, this is not my conversation. I'm simply trying to get people to think about the economics of this.
Okay. Given the world has decreasing fire, can you address the United States? It seems we have had tremendous wildfire issues these past few years! Exclamation point.
Yes, and I love the exclamation point.
Three of them, actually.
If you look at U.S. fire, so I show we have good data. So we have forest fire data back to 1926, and we have good model data at least back to 1900. And what you see, and I didn't bring this, well, I have the slide, but I can't just show it to you. It looks like this. You can look up my latest article from 2020 that also shows it. It looks like this. It was incredibly high in 1900. Then it's been declining, and it reached a low point in the 1960s, 1970s. And since then, it's been increasing slightly. So that there is a real increase. Much of this is probably because we managed to dramatically reduce fire by basically, what is the word? Fire suppression. And once you do this sufficiently much, you build up a lot of extra fuel, and then eventually you will see a higher equilibrium point. A lot of people will only show you that last bit of the graph, which is true but in a historical term, very, very unrepresentative. I want to just emphasize, over the last 20 years, did any one of you notice that the US had much less fire in 2020 and in 2021 than you had on average for the last 20 years? No, because that's not how news works. News works by somebody taking a film crew to where it's burning. You know, there's no reporting. I'm out here where there's no burning at all. And it hasn't burnt here the whole year. Right? It's just not a news story, but it doesn't mean we're well informed. Yes, there are huge problems in California, and one of the points that a lot of people, so there's a big paper in Nature last year that basically said you have to make prescribed fires of about 20 times more than what California is actually doing every year. And they're not doing it because a lot of people, a lot of well-meaning people, are basically saying, I don't want that extra air pollution. I totally understand if you live next to one of those places, you'd rather not have it. But of course, if the alternative, if you knew that, was that eventually your house will burn down, maybe you'd be like, okay, I'll cough for 1 year, for 1 day a year. So we need those conversations. But again, this becomes, no, this is because of climate, just like the hurricanes and all these other terrible things. So you see this heat dome. And this was absolutely real. A lot of people died because of the heat dome, so probably 715 people. But I'm sort of a little surprised that every year, according to the Global Burden of Disease, about 2,500 people die in US and Canada from from heat every year. Why are we only looking at the 700 that made the news? And more importantly, 130,000 people die every year in the US from cold. Why don't we ever hear about them? I know why, because when people die from heat, it happens very quickly, and it's a great news story. When people die from cold, it happens because they can't afford to keep their homes heated for months on end, and so they are a little cold, and their blood vessels contract, and so they get slightly higher blood pressure, and we know that that's one of the main reasons for getting heart attacks and all kinds of other bad things, so you die a little more. But it's not something, you know, people just die in these anonymous apartments without anyone and any CNN crews noticing. But it doesn't mean it's a right way to think about it.
Okay. Your data is compelling. Why are the top experts on Earth getting this wrong? Example, Germany's climate envoy just said that Germany will accelerate its commitment to the energy transition even with the war. There are smart people in Germany. What gives?
Yeah. So I think the fundamental problem here is that there's so much data out there, and there's so many different stories that it's very easy to pick whatever you want to listen to. And then there's, of course, also a lot of politicians who have sort of hooked up their entire careers on saying we should go green. So Germany, very clearly, for 20 years have been saying, we want to go green, we want to show the world how it's done. If anything, they've managed to show the world how it's not done. But the fundamental point is they still want to say, well, if Ukraine is a really big problem, what that shows us is we should have more solar and wind so we wouldn't be in this pickle. But of course, the problem is this is exactly why you're in the pickle, because you need something for when the sun isn't shining and the wind isn't blowing. It's not really rocket science. That's what you use the gas for. You could use coal, but of course, there's all kinds of other reasons why you might not want to use that. And I think we should accept what Tesla say. If you want to use coal, you should have much stronger environmental regulations, because coal really does kill several million people because of air pollution. We know how to fix that, but it's costly, and you should have a talk about that. But you could also use nuclear, and again, nuclear currently is too expensive, so you need to think about fourth generation. There's all these sort of knock-on effects, and that's why it's so easy for politicians to say, you know what, I get that it's really hard to get gas from Russia right now, but in just a few years, we'll all have solar and wind. We heard Tesla say that up here just like 2 hours ago. It sounds really cool, but it's just fantasy. It's not going to happen because you need some backup power. And that backup power undoubtedly will be fossil fuels, at least for the foreseeable future.
Okay. What do you believe is the motive behind the exaggeration of climate claims? Is it related to the Great Reset goals of the World Economic Forum? And first, you should probably define Great Reset and how that's related to climate policy.
So it's very hard to tell exactly what's behind all of these people. I mean, I've met a lot of people. I had the opportunity, so Andrew Dessler and I have debated several times on Twitter, which is never a great platform to do that. And he said, I hope you're not really annoyed with me. And I was like, no, I mean, this is what happens, right? But my understanding is that most people in this debate, and I think it's also just a good sort of a way to approach a conversation, most people in this really do want to do good. Most of the people I met with, so Al Gore and everyone else, they also want to do good. Look, they also want political power and get rich and all kinds of other stuff, and you can't blame them really. So I think the honest answer is to say they want to do good. Most of the world is telling them the way you do good is to go further down the line of reducing carbon emissions. And that is in some small way true, but there's all these other things. So again, it's back to this, do we want 450% or do we want 434%? Of course we want 450%, but unfortunately much of what many climate people or climate campaigners are actually achieving is perhaps only making us 300% as rich. So in some sense, we're arguing about how we think about the world when we don't just talk about climate. And I think a lot of climate people really don't think any other way. I don't know if you saw, John Kerry was interviewed right after the war in the Ukraine broke out. And they said, he was also led into this question. They asked him, how's this going to affect global warming? He was honestly saying, this war is going to emit a lot of CO2. And it's probably also going to take away our attention for global warming, which seems just sort of incredibly short-sighted and sort of wrapped up in your own world. But yeah, I'm pretty sure if you talk to one of the people who arranged a local dog show in Hungary, she would probably also be really annoyed that this is totally disrupting her dog show, and she's like, why couldn't they pick a better time for that war in Ukraine? And I get that people are there, but of course, so it's not really John Kerry's fault. He is certainly right now on this planet to make us care about climate change. It's our fault for allowing them to say that's the only issue. And that's why we should keep coming back and say, I'm sorry, yes, biodiversity and extreme weather and failure in climate action, but maybe also pandemic and Russia and China and inflation and all these other things. And maybe that first. I think that's the way to have that conversation. So I don't think they're evil. I don't think there's this grand, nefarious sort of conspiracy. I think it's just a lot of people love to just jump on whatever bandwagon there is. If you think back to the 1970s, when you read all of that stuff, I think it's sort of telling how everybody knew we're going to run out of everything and we're all going to starve. If you read, there was this wonderful story for the first Earth Day in 1970. It was made up as a report to the president in the year 2000. And it was talking about how, about the 26 million Americans left over in 2000. They were sort of scrounging away, and they were plowing the fields in the middle strip of the highways in Los Angeles, and eking out a meager existence of their world. And it seemed true at the time. Most people actually bought into this. It was not because we didn't know better, and most people were telling you're wrong, most of the experts, but it just felt right, and everybody just jumped on that bandwagon. I think that's the same thing that's happening here. And so again, I think the crucial bit is to tell people these very specific instances. So for instance, how many people died in the 1920s? How many people die today from climate? Oh wait, it's actually declined dramatically. That probably tells us something. Do you want to have a chat about that? That's a way to get a better conversation.
What countries are the most honest about the climate and their climate policy? Do any of them echo your sentiments, and is Russia funding the green movement?
So Russia probably, Russia was certainly funding the anti-fracking movement in Europe. How much is very, very unclear, but it makes sense for them to do so, right? Would you rather have people buy your product or find a way to make it yourself cheaper. Of course you don't want that. So Russia and Putin has several times said, I'm really worried about the impacts of fracking. And you're kind of touched that he really worries about that. But a rational Putin would do exactly that. So I get that point. Sorry, your other part of the question.
Which countries are most honest about their climate policy?
I would love to be able to say that there's some really smart countries out there. I don't think so because as Kuhn also mentioned, when you talk to a lot of political leaders in private, they kind of know this, but it's just a vote killer. If you go out and say, you know what, that climate change, no, I'm not going to buy into that. That's just, that's going to kill you in so many different ways. So most countries seem to have this competition. We're either going to do it really badly, or we're going to be proud and do it slightly less badly. Well, that's the way of the world. I mean, I experienced that firsthand in Denmark, where I was advisor to the government at some point, and the prime minister was just, yeah, we're never going to survive this. We're just going to jump over there and worry about climate, but perhaps slightly less badly. And that's what most countries do. I think our point has to be to make sure that we at least expand what's possible so we can maybe do it even less badly. We have a great saying sorry, no, you can't say that because we have a saying in my organization, the Copenhagen Consensus. It's not about getting it right. It's about getting it slightly less wrong. If we could make the world a slightly less wrong place, that'd be amazing. So let's try and do that.
I have 1 minute left. Are we close to ever creating sustainable fusion energy? For example, the progress that China and the UN have made with ITER and tokamak, if I'm saying that correctly. Could it solve the carbon emissions and energy problems for the whole planet?
It would be amazing, right? I don't know enough about this. I know that we've heard a long time that, it's going to be incredibly cheap. Do you remember the too cheap to meter from fission? Yeah, there's always this technology optimism. If I was a guy working in fusion, you did that at one point, Chris. You'd be around telling everybody how this is just this close. We just need another $100 billion, and then we're ready to go. And I would probably say we should give him, I don't know whether the right number is $100 billion, but the point is research is incredibly cheap. So we should be spending money on fission and fusion and batteries and solar and wind and Craig Venter's great idea and all these other ideas out there because they're incredibly cheap, so we can afford to do all of it. Most people don't know this. In Paris in 2015, the world signed this grand treaty that nobody's actually living up to of cutting carbon emissions. And of course, even if we'd done all our promises, we would only get very, very tiny part of the way. But this was what everybody heard. But on the sidelines of Paris, President Obama and a lot of other world leaders and many of the world's richest people, including Bill Gates and many others, actually met on the sidelines. I'm happy to say we had a tiny bit we were a tiny part of the reason why this happened. They met in the mission Innovation, where they promised solemnly to increase their spending on research and development into green energy, to actually double it by 2020. Of course, we did no such thing. The world increased it slightly, but we're nowhere near that. I would argue we should increase it sixfold. That was what our Nobel laureates told us. The point is, increasing our spending on research and development into green energy sixfold would still just be about 20% of the current cost of what we're spending on renewables. So again, we need to get people away from this, here's another solar park or another wind turbine park, and ask instead, should we fund a few more of those eggheads? Because that's the thing that'll actually save the planet.
All right, the clock has struck 1:30. We're on time. Bjorn Lomborg.
Thank you very much. Thank you.
Of course. Enjoyed it.